Hello and welcome to topic 1.1, undefined and defined terms. Believe it or not, there are words that do not have definitions. In geometry, the first lesson is talking about these words. For example, try to define what a point is. Go ahead, pause the video. Think about what a point is. Okay, now you're back. Did you figure out what a point is? A point, the best way we can describe it is that it has zero dimension. We're talking about dimension, so it's just like this. But that's not really a point, because this point has some width and it has some height to it. So this is not actually a point. A point doesn't actually exist. It only exists in our mind. So wow, welcome to geometry. It's represented by a dot and an uppercase letter. The uppercase and lowercase letters actually mean something, so you got to be careful. And so we'll put like a point, and we'll put an A next to it. So this is now point A, and this is point B. All right. What you can't do is like do point lowercase t. That doesn't work. We don't do that. So not like that. Next, a line. What is a line? Think about what a line is. Can you come up with a definition for what a line is? Pause the video just for a moment and think about what a line is. Okay, you're back. A line is one dimension and extends forever in two directions. That's right. Every time you go up a dimension, you get two directions. So for a line, you get left and right, two directions. Yet it has no width or height. So this is not actually a line, because this has a little bit of height to it, doesn't it? Like you can measure the height. It might be like a millimeter. So actually a line only exists in our heads. There's really no such thing as a line. The closest thing we can get to a line is kind of like a light, a ray of light being shown, but that's more of a ray. All right, let's see here. Through any 2 points, there's exactly one line. You can take any 2 points in the universe and connect them with a line. So for example, I can connect these 2 points, and that goes forever that way, and that goes forever that way. I can't draw that, but that's what those little arrows mean. You can use any 2 points to name it. So even though it might go through more than 2 points, you can use any 2 points to name it. Represented by a line with 2 arrowheads like the following. So this is now line AB. We'd call it line AB. I can tell it's a line because it has a little arrowheads. So example 1, name the above line 3 different ways. We could call it, that's the way you write that, that's line AB. The order doesn't matter because it's the same line. Line BA is also the same. It doesn't matter which way you wrote that. Or uppercase letter and lowercase letter matters. If there's like a little lowercase n up here next to it, you could call it line N. Alright, so there's lots of ways to name things. So look for the lowercase letter, or just find 2 points and you can call it the line. Alright, the next thing is the plane. So we're going up to 2 dimensions, and we're going to be stuck in 2 dimensions for quite a while, actually, until we get to the last chapter, actually. So we're stuck in the plane for a long time. In fact, yeah, there we go. 2 dimensions. So now we get 2 new directions. Every dimension you increase, you get 2 directions. So in a plane, in a plane, you can move to the right, you can move to the left, you can move up the plane, you can move down the plane. So that's 4 directions now. When you get to 3 dimensions, you get 6 directions. You get left, right, up, down, forwards, and backwards. Alright, so a plane is a flat surface. Alright, so imagine like a piece of paper or a desk. It's flat. You can't come out of the plane, you're stuck in the plane. That extends forever, yet has no thickness. So just like this line up here goes forever, the plane also goes forever. Okay? So even though we draw it with boundaries, this plane is going forever. So actually a plane does not exist. It only exists in our minds. We can only think of forever in our minds. You can use any 3 points this time. So a plane requires 3 points. A line requires 2 points. A plane requires 3 points. Here's a diagram here to help you figure that out. You can pick any 3 points in the universe, and you can make a flat surface through those. Or like I like to think of it like this: could you make a spider web with 2 points? Would that be a successful spider web? How many points does a spider web need? Because a spider web needs to be like a flat surface. And so if I make a 3rd point, I now have a flat surface to work with. Alright, so if you can make a spider web, you can make a plane. It can be any 3 points. It can be like these corners of this box right here. Think spider web, there we go. And then through any 3 points that are not on the same line. Oh yeah, that's another one, not on the same line. Can a spider make a web through these 3 points? That would not be a successful spider web. It has to be 3 points not on the same line, and then we can make ourselves a nice little flat surface there. One can make exactly one plane using 3 not on the same line. This not on the same line thing, that'll probably show up on some tests and quizzes, like true or false, 3 points make a plane. Well, it's actually false. It's 3 points not on the same line will make a plane. So you got to be careful for things like that. It's represented by a shape that looks like a floor or a wall. This is like what you'll see a plane. Yeah, a plane could be a triangle too. It just has to be any flat surface. Represented by a shape that looks like a floor, like the following. So here's a plane. Notice we've got uppercase letters for the points, and we have a lowercase letter in the corner. That's interesting. So name the plane 7 different ways. So there's lots of ways to name a plane. You just have to state 3 points that are on the plane. So this is plane ABC. That's it. That's how you name this plane. Or you could say plane BCA, or plane CAB, or plane BAC, or plane BC, nope, ACB, and I'm missing one. CAB, CBA, CBA, there we go. So basically order doesn't matter again, but for a plane you have to use 3 points. And then, just like with the line, if there's a lowercase letter, you call it line N. Same thing with the plane. If there's a lowercase letter there, you can just call this plane. Actually, that's supposed to be uppercase for a plane. I don't know why that's lowercase. Call it plane M. Alright, the line has lowercase, the plane has an uppercase. You can name it with an uppercase letter. Like here, you could call this plane R. There's no point R, you could call it plane R. Alright, so there's our undefined terms actually. These have no definition, point, line, and plane. And actually there's a couple more. The word lie on, to be on something, we don't really have a definition for that, believe it or not. Try to describe the word on without using the word on. And also the word between. The word between doesn't have a definition. Try to describe the word between without using the word middle. Because if you use middle, like this point here, yeah, maybe it's in the middle of A and B. But what about this point? Is that in the middle? Is that exactly in the middle? No, but it's still between. So actually there's not a very good way to describe the word between. It just is. Alright, so B lies on line AB, and X is between A and B. Okay, so now that we know these things that are not even real, we can now build, we can now build the geometry. So here we go, defined terms. These are now some defined terms. We can use these undefined terms. Collinear, like co-captains or co-pilots, like they're on the same team or the same plane. Collinear, they're points that lie on the same line. So in this picture here, points S, P, and T are collinear. Notice I'm naming 3 points because any 2 points are collinear. You can actually draw a line between any 2 points. While points S, P, and V are non-collinear. You cannot make a line with S, P, and V. And then same thing, coplanar. I wonder what that means. Co means same, so points that lie on the same plane. So in this scenario, you have to name any 3 points lie on the same plane, so let's name 4 points. So for example, S, P, T, and V are coplanar, while points S, P, let's name this point X. This is like above the plane. Alright, so this is shooting above the plane. S, P, T, S, P, X. Sorry, hold on. S, P, V, and X. You don't really get the perspective here because it's on a flat piece of paper, but what's really happening is this line right here is really doing this. Hold on. It's really shooting out through the plane. Alright, so that's actually what's happening, and that's what this diagram is supposed to show. And the dotted lines right here are hidden. You're not supposed to be able to see those. So it's actually behind the plane. Okay, well, I just ruined my diagram. Line segment. A line segment consists of 2 endpoints, and all the points between them. So now we discuss the word between, I can use it to make new words. An example of a line segment is, for example, line segment ST, which is pronounced segment ST. Alright? Segment ST is the same thing as segment TS. So segment ST and segment TS are exactly the same. Notice the little line I put above it, which is different from this. This is a line, which means it goes forever. It goes beyond A and beyond B. And this is segment ST, which means that it's bounded by S and T. Bounded. And then array. Array consists of an endpoint and extends from that endpoint in one direction. An example of array, well, my diagram is not doing very well right now. Let's use this picture. Ray AB. There's ray AB. Notice the symbol I used above it. It means it's starting at A and it's extending through B. So it's starting at A and it's extending through B. Does it go this way? No. That's ray AB. Or you can draw another one. Starting at A, going through B. Ray AB. Which is different from ray BA. Ray BA starts at B and goes through A, so it's going the opposite direction. So when I say ray AB, I mean it has an endpoint A and extends through B. This is different from ray BA. Opposite rays. 2 rays that have a common endpoint but extend in opposite directions. One of the rays goes left, one of the rays goes right. Or one of the rays goes up, the other ray goes exactly down in the opposite direction. An example of opposite rays are lost my picture, but this would be opposite rays. Here's an example of opposite rays. Let's say we have, really shouldn't have demolished my picture. Let's say we have A, B, C on a line. So an opposite ray would be, starting at B, we could do ray BA, and we could do ray BC. Notice that they both start at B and they extend in opposite directions. Alright, here's something for you to think about. If point Y lies between X and Z, so this word between, then you're going to have to make sure that you are able to draw a picture like this. Let's draw the picture. Y is between X and Z. Alright. Then, what are the opposite rays here? So name the opposite rays here. We're going to start at Y, we're going to go through X. So we're going to say ray YX. And we're going to say ray YZ. Alright. So in summary here, this symbol, we have this for, say, like, that's segment AB. That's ray AB, and that's line AB. A couple symbols here. Alright, I'm going to stop the video and start on the back side in part 2.